Greetings, flat earthers, and I came across some very interesting article. Okay, I already knew about this, and it is explained in heliocentric model, which is of course wrong. And let me start with reading the interesting part. Let's start with this. Because the direction of the Earth's tilt changes in relation to the Sun, the northern and southern halves of our planet get different amounts of sunlight over the course of the year. In the northern hemisphere of the Earth, the axis points most toward the Sun in June. Because the Earth is leaning toward the Sun, it receives direct rays of sunlight and is warmer and seen in the image below. Okay, let's see this image. Okay, so the Earth is further from the Sun. Okay, so what we have, it is summer and northern hemisphere, and summer is not so hot. Okay, because of the increased distance of the Earth and Sun, while in the southern hemisphere is winter, and winter is very cold because the Sun cannot heat this southern hemisphere. Okay, it kind of makes sense, although it's not true. Okay. On the other hand, the Earth's axis points most away from the Sun in December. Because the Earth is leaning away the Sun, it receives the least amount of direct rays of sunlight and is cooler, as seen in the image below. Okay, it's winter in the northern hemisphere, so the Earth is closer to the Sun, so the winter is not so harsh in northern hemisphere, while the summer is very hot in the southern hemisphere. Okay, it's quite the opposite. So you wouldn't want to be in southern hemisphere at all in any day of year, maybe in spring, fall. Okay, so we saw this. Let's see some pictures, and I have my explanation of this. Just let me find this. Okay, because the sun is moving at some speed, and it increases its velocity as it is going to the south, and decreasing velocity as it goes to the north. So the sun gets hotter and colder throughout the year. So it gains intensity or loses some of its intensity because of the speed. And the main reason for this because it is circling in Earth's magnetic field. And how does this field looks like? Well, similar to this. Picture this ring magnet, and it is all south pole on this upper side, and we have north pole in the center, and mostly it is beyond the dome, this south pole magnet. I'd say the magnet itself, and who knows how further this magnet goes. It could go indefinitely, we don't know, and we know that only this part of the where at flat Earth is clear. It's like a puddle or something. Okay, so you saw this, what I mean by that. So I made some calculations, and let me show you. Okay, here they are. Okay, just bear with me, okay? This notebook is very slow. Okay, so as you see, we have three circles, and this yellow one where is summer in the northern hemisphere, and the radius is smallest, and the speed is smallest. It's 768 miles per hour. It is this yellow circle and yellow dot. Okay, when it's in equator, it is spring fall. It is orange circle, and it says 1044 miles per hour, and that is supposedly spinning of the Earth in the equator, which is not. And we have this red circle. It represents the winter in the northern hemisphere and the summer in the southern hemisphere, and it is where the sun is having highest speed or velocity, 1316 miles per hour, and in that part of the year the sun is hottest, and that's why in the southern hemisphere the summer is hotter than summer in the northern hemisphere. It makes sense. It perfectly makes sense. Okay, let's now see how it works with some technical details. Okay, let's zoom it in. This is magnetic perpendicular to the magnetic field at some velocity, and it induces EMF force and the current, thus generating the heat, the light, and also ultraviolet light, infrared light, visible light, radiation, you name it. And it perfectly corresponds with our flat Earth. And it is the formula EMF, electromotoric force, the number of turns, okay, displacement of flux and displacement of time. So the fastest it goes, this wire, the more displacement of flux is, the more this EMF force, and the more the current, and also other effect. So you get the picture, okay. And just to be more clear, okay, hold on a sec. Okay, you can picture this as the sun, this disk, and in the magnetic field, it's homogeneous magnetic field. We have this, okay, amp meter. Okay, just to be clear, okay. And just one more picture, last but not least. Okay, the duration of the day and night throughout the year. So it's not the same in the summer and the fall and the winter. Okay, let's fit this in. Okay, this is in June. Okay, and this spot of light, like headlight, it is influenced the magnetic field, and it's strongly influenced because all this light is contained within this ring magnet and cannot go any further, as you can see. So it perfectly explains midnight sun at Antarctica and the midnight sun at North Pole, and equinox and solstice, and you name it. It is perfectly explained within the flat Earth model. Okay, so not only that the sunlight is avoiding and diverting from the outer south pole ring of the magnet, it is also diverting from the north pole of the Earth, this inner pole, and the light bends in the presence of magnetic field. It is already proven, so no debating here.